Today what I want to talk about is how to factor a trinomial. A trinomial is a polynomial that has three terms. There are a ton of ways that we can factor trinomials, but this is the one that I'm going to show you, and it's called the X box. There's three main steps to the X box. We're going to identify our A, B, and C. We're going to use a box or a rectangle, and then we're going to use an X to help us structure the problem. Our ABCs are our coefficients in the problem. So A in this problem would be 6, B would be 1, not X. ABC should be like 1, 2, 3. They should be numbers. And C is -2. What we really need from the ABCs is our B, because B is going to swing over here to the bottom of the X. B goes at the bottom. Next, we're going to start filling in our box. So our first term goes in the first box, and our last term goes in the last box. One of the patterns you can notice after you do a lot of these problems is that when I multiply the diagonals, I get the same thing. So we're going to use that. That 6x squared times -2 would be -12x squared, and my other diagonal that's currently missing should multiply to the same thing. That coefficient, -12, goes at the top of my x. And now I ask the question, what two numbers multiply to 12, and since I have a -12, subtract to 1? What two numbers multiply to -12 and subtract to 1? And those two numbers are 4 and -3. Those numbers come back into our box as 4x and -3x. You have to have the x's there because, once again, that diagonal would multiply to -12x squared. And the x squared comes from doing x times x. Also, our whole goal is that we're rewriting the original problem inside the box. Since I have three terms to start with but 4 spots in my box, we have to split this middle term. And so if I look at this diagonal, I have 4x minus 3x gives me 1x. I'm just going to erase a little bit of this so that it's a little bit more clear. So what we're going to do is, at this point, we're going to get to the outsides of our rectangle. We really are using something called the area model. In this problem, I'm given the area and I'm trying to find the outsides. So what we do is we find the GCF of the first row. So what's the biggest thing that goes into 6x squared and 4x? That would be 2x. Now I'm going to try to fill in the top row, or the length of my rectangle. What times 2x would give me 6x squared? That has to be a 3x. What am I going to multiply to 2x to get 4x? 2. Now I move down to the side. What do I multiply to 3x to get -3x? -1, and then we can always check with our last box. -1 times +2 gives me a -2. The answer to a factoring problem is to rewrite it as multiplication. So 2x minus 1, my side, times the top, 3x plus 2. Once again, the answer to a factoring problem is to rewrite it as multiplication. We haven't solved anything. There's no equals. We're writing something that's the same or equivalent to what we started with. So let's look at another example. First step is to identify your ABCs. A, B, C. Then we're going to start with filling our box, and then we're going to solve our x. So my A is 6 again. My B is -5. And my C is -4. The key one here is that B goes at the bottom. Now we start to fill our box. First term, first box, last term, last box. Then we multiply the diagonal, and that gives me -24x squared. I'm going to put that at the top of my x, but I'm just going to put the coefficient, -24. So we're looking for the two numbers that multiply to -24 and subtract to -5. So it's going to be an 8 and a 3, and I have to decide what the sign is. If I did 8 minus 3, it'd be a positive 5, but 3 minus 8 will give me the negative 5. The reason I'm doing this is so that I can rewrite my middle term as negative 8x and 3x. It doesn't matter which order I put the negative 8 and the 3x. But just make sure you have an x with both of those, otherwise you're going to start getting confused. Last part is to write it outside of the box. So what's the GCF, or what's the biggest thing that goes into 6x squared and negative 8x? 2x. Now I'm going to fill in the top. What do I multiply to 2x to get 6x squared? 3x. What do I multiply by 2x to get negative 8x? Negative 4. What do I multiply to 3x to get 3x? 1. And double check your last box. 1 times negative 4 does give me negative 4. And your last part is to write your answer as a multiplication problem. 2x plus 1 times 3x minus 4 is my final answer. (3x squared minus 2x minus 5). So give your A, B, C. Your A is 3, your B is negative 2, and your C is negative 5. Draw your box. First term, first box. Last term, last box. Multiply your diagonal, which would be negative 15x squared. Now we're going to do our x. The negative 15 goes at the top, but what goes at the bottom? That's from the beginning of the problem. B goes at the bottom. So we want to say what two numbers multiply to negative 15, and in this problem subtract to 2. Negative 2, sorry. So the answer to that, it's going to be a 5 and a 3, and it needs to be 3 and a negative 5. So negative 5x and 3x. Now we take out our GCF. What's the GCF, or the biggest thing that goes into 3x squared and negative 5x? All that you can take out is an x. Don't overthink it. What times x is 3x squared? 3x. What times x is negative 5x? Negative 5. What times 3x is 3x? 1. And double check your last box. 1 times negative 5 is negative 5. Final step is to rewrite as multiplication. X plus 1 times 3x minus 5. Let's look at one of the problems that trips people up a lot. So many places in this particular question could trip you up. The first is identifying A, B, and C, because a lot of people are going to say A is x squared and B is x or negative x. But remember, your A, B, C's are like 1, 2, 3. They're numbers. So A is 1, B is negative 1, and C is negative 72. Fill your box. First term, x squared. First box. Last term, last box, so negative 72. Multiply your diagonal, so negative 72x squared. And let's fill in our x. So the negative 72 goes at the top, and b goes at the bottom. So we want the two numbers that multiply to negative 72 and subtract to 1. This 1 really confuses people. When there's a 1 at the bottom, it means that the numbers are 1 apart. So what two numbers are 1 apart from each other and multiply to 72? That needs to be 9 and 8, and for it to be a negative, it should be negative 9. So negative 9x and 8x. Take out your GCFs. Once again, don't overthink it when it's a problem like this. It's just going to be x. What times x is x squared? X. What times x is negative 9x? Negative 9. What times x is 8x? 8. Double check your last box. 8 times negative 9 is negative 72. So x minus 9 times x plus 8 is your final answer. All right, let me do one more because I just realized all of those problems had some sort of subtraction going on. So let's do this one. X squared minus 14x plus 40. So let's identify our A, B, and C. A is 1, B is negative 14, and C is 40. Fill your box. First term, first box. Last term, last box. Multiply your diagonal. 40x squared. Start your x. The 40 goes at the top, and your b from earlier goes at the bottom. So now we're looking for the two numbers that multiply to 40, and that's a positive 40. So now I'm looking for the factors that add to negative 14. Multiply to 40 and add to negative 14. So 10 and 2 gives me, 10 and 4 gives me 40, and 10 plus 4 gives me positive 14. So if I make it a negative 10 and a negative 4, negative 10 times negative 4 gives me the positive 40, and negative 10 minus 4 gives me the negative 14 I need. So negative 10x and negative 4x. Take out your GCF of the first row, which is just x. What times x is x squared? X. What times x is negative 10x? Negative 10. What times x is negative 4x? Negative 4, and negative 4 times negative 10 does give me positive 40, so it checks out. Final answer would be x minus 4, the side, times the top. You could really do the top times the side. I just always do the side first for some reason. So hopefully that helps clarify a little bit with Xbox.